Good day, students. Welcome to new week. So we are at week 5. You are welcome to today's class, which is the mathematics class for JS1 and as a revision class to JS3. This is approximation. Our topic for today is approximation. And approximation is just a word that simply means nearness. It simply means nearness. It is very, very appalling that some students don't understand approximation. When they are doing approximation, they will change the value completely and they will tell you that it is what? Approximation. But please, I want you to pay attention to this today's class so that you will understand vividly what is actually approximation and what it entails. So our specific objective of the day of today's class is that at the end of this lesson, that is you, should be able to A, define approximation. Define approximation. Then 2, approximate values based on place value. Approximate numbers based on place value. And our third specific objective is that we should be able to approximate numbers to the nearest whole number, decimal places, and significant figures. So what is approximation? We say approximation simply means nearness. This means that there must be that closeness between the approximated value and the actual value. What are they saying? Is that whenever you are approximating a number, you don't change it totally. You must see that proximity, that nearness, that's almost between the two numbers. Like for instance, you see, look at this example. We said you should approximate 9,784 to the nearest 10. You should approximate 9,784 to the nearest 10. Now, when you talk about nearest 10, you see that 10, it is 0 and 1. So our required point becomes 1. And if you trace the required point from 9,784, the required point is 8. So the next thing we consider, which you are going to observe in the next slide, you understand that the next thing you need to consider is the next number after the required point. And in this case, the next number is 4. And 4 is categorized under 0. So that is why we now have the approximated value is 9,780. You see that 9,780 and 9,784, there is that closeness between the two. But some students will approximate the value to be they might approximate the value to be 978, forgetting to put that 0 there, unknown to them that 0 that they did not put have changed the figure completely. So it is no more the approximated value. So if you did not put the 0, it will become 978. So what is the closeness between 978 and 9,784? There is no closeness. So that is why we must be critical in this topic. So you see, unknown to them that there is no any closeness between 9,784 and 978. So now you find out that we have techniques in carrying out their approximation. We have techniques, but before you look at the techniques, you see that I write out the figures for you to understand. Like here, the original figure is 9,780. That is the original figure. Why the approximated value we obtained was 9,780. Why the one some people can put as their value, they will put 978, which is totally wrong, totally far from the original value. So you understand that there are techniques in approximating numbers. There are techniques we use in approximating numbers. What are the techniques? I have three things here for us to put into consideration. The first one, we talk about the word underline the required figure or reference point. We call it required figure or reference point. Then the next thing we consider again, it is the word figure after the required point. The figure after the required point. After you underline the required figure or required point or the reference point, the next thing you look at, what is the next number after the figure you underline? That is the final the factor that will decide if you are rounding up or you are rounding what? Down. So after doing all these things, the third factor you consider, it is that after you have done your approximation, every other number after the required point should be what? 0. Every other number after the required point should be what? 0. So let's look at them. I said underline the required figure or reference point. This point is obtained by the word approximation required. By the approximation word required. Like if you are asked a particular question, approximate the figure, a particular number to two significant figure. Now they say you should approximate it to two significant figure. It is this two significant counting that will give you your word required figure or reference point. So when you do that counting, it will now be you will now land at a particular figure. That means that you have obtained the required word point. So now after you've obtained your required point, the next question is that what is the number after the required point? The number after the required point, the nature will tell us if we are rounding up or we are rounding down. If the figure is between 0 and 4, we round down, it becomes 0 automatically. But if the figure is between 5 to 9, we consider it to be 1, then we will now add it to the required word figure. So when you add it to the required figure, then what next? Then the next thing is that every other numbers outside the required point should be what? 0. So now, with this example, you see that we have what? 1234 as the original number which I used to do this demonstration. And when they say to two significant figure, we do the counting 1, 2, and 2 becomes our required point. So in the step 2, we look at the next figure after the required point 2, which is what? 3, and 3 is among the 0. So that is why we just leave the 1, 2 there. So the next thing is that the third technique is that every other figure should be 0. Instead of us writing 3, we put 0. Instead of us writing 4, we put what? 0. So the approximated figure becomes what? 1200. But the original value was what? 1234. I hope it is very clear. So now let's look at approximation by placed value. What do we mean by place value? You see, sometimes in approximation, they might ask you, round this thing to the nearest 10, to the nearest 1,000, to the nearest 100, to the nearest million, to the nearest billion. This is the techniques you use. What is what? Placed value. You see that every figure in a number have their place what? Value. Look at our example here. We have what? 3,456.789. 3,456.789. So from here you know that what? 6 is a unit, 5 is what? 10, 4 is what? 100, 5 and 3 is what? 1,000. So the next figure after the decimal starts with what? 10. So 7 becomes what? 10th, 8 becomes what? 100th, and 9 becomes what? 1,000. So these are the word place value. So whenever you are asked such question, you should use the place value as your required point. The place value will become your word required point. So look at this example. They said approximate 342,723 to the nearest A 10, B 100, C 1,000, D 10,000. So if you look at your word from this figure, 348,723. So 222, that is the 2 now becomes the word 10. So 222 is at the what? 10 position. So when we have 2 as our required point, the next thing you are looking at, it is the what? Figure after the required point. So if 2 is our required point, then the figure after our required point is what? The figure after our required point is what? 3. So 3 So 3, please observe this thing, please. The 3 at the end supposed to be 0. It's not equal to, please. The 3 at the end supposed to be what? 0 is an error. So the 3 at the end supposed to be what? 0. So when you look at this 2, the next number is what? 3, and the 3 is what? 0. So our figure is supposed to be what? 3, the approximated value is supposed to be what? 342,720. Please, it's not what? 342,723, the same as the main value. No, it is what? 342,723. So now let's look at what? The B aspect. B aspect is what? 100. B aspect is what? 100. So now 100, you see 100, our required point is what? 7. So you look at the next value is what? 2. So 2 is among the what? Zeros. So that is why we have our answer as what? 342,700. Then C, you look at what? They said thousands. So in the 1000 position, it is the second 2 that is at the 1000 what? Position. So since the second 2 is at the 1000th position, then we look at the next figure. What is the next figure? The next figure is what? 7. So 7 is among the 1, which is among 5 to 9. So it becomes 1, and added it to what? 2, it becomes what? 3. So that is why we have what? 3, 4, 3. So the remaining figures now, we turn them to be what? 0, 0, 0. Then for 10,000s, you know that what? 4 is at the what? 10,000th what? Position. Place value. So now we use this thing to approximate. You look at the next value, which is 2, and 2 is among the what? Zeros. So that is why we have what? 340,000 as our final answer. So let's look at example 2. Example 2, we are talking about the approximation by what? Placed value. So you look at this example that said you should approximate what? 0.05264 to the nearest A, 10, B, 100, and C, what? Thousands. So the next thing you look at, what is at the place value of what? 10th. So you look at what? 0, there is 0.0. The second 0 is at the what? 10th position. So since it's at the 10th position, that 0 is our required point. Then the next figure after 0 is 5, which is among the 1. So make 5 to be 1 and add it to what? 0, it becomes 1. That is why we have what? 0.1. Then B, they said 100th. And what is our 100 there? Our 100, the value that is taking the 100th position is what? 5. So that means that since 5 is taking the 100th position, look at the next figure after 5 is 2. So it's among the zeros. So we'll still have what? 0.05. So the next one is what? 1000th. And what is taking the 1000th position is what? 2. 2 is taking the 1000th position. So we look at the next figure after 2. What is the next figure after 2? Which is what? 6. So you make 6 to become 1. Add it to 2. It becomes what? 3. Which is 0.053. I hope this example is very, very clear to you. Please, if there is any other question, you are free to call my line. But don't call my line at any time. I might be available for you to call anytime from 8 p.m. 8 p.m. Let me just say from 7:30. You can try my line. If it is close to me, I will attend to your question, and you will be more what? Okay. At any time, at that time, if you call me, I'll be able to attend to you. But if you call me any other time, I might not attend to you. So now we are talking about approximation by significant word figure. So significant counting, we do not count 0 as significant word number. So 0 only becomes significant if it falls within the significant numbers. What are the significant numbers? The significant numbers are what? 1 to what? 9. So 0 can only be significant only when it is in between 1 to 9. So now look at this example. They say we should express this one to 1 significant figure, 3 significant figure, 4 significant figure, and what? 6 significant figure. So now in this case, the significant counting begins with what? 6, because it is 6 that is a significant number. The two zeros, the two first zeros, they are not what? Significant. So when you want to count, you start from what? 6. So when you start from 6, we count. Once significant counting means that 6 is our what? Our first significant number. So it becomes our required point. So we look at the next number. Is it among the 0 or the 1? So that's mean that 5 is among the 1. So add the 1 to 6, it becomes what? 7. So that is why our answer is what? 0.07. So B is set to 3 significant figure. So 3 significant figure, if you count 3 significant figure, you find out that the 0 between 5 and 7 is now the what? Required point. So we look at the next number, which is 7. Is it among the 1 or the 0? We know that it's among the what? 1. So add it to that 0, it becomes what? 1. That is why our value is what? 0.065. Instead of us writing 0, we put 1 because of the approximation. So the next one is what? C to what? 4 significant number. And the next one, which is D, is to 6 significant number. So if you check the exercise, I hope you'll be very, very what? Cleared. So the next thing we are looking at what? Decimal place. When you are approximating, you might be hearing something like approximate this to 2 decimal place, to 3 decimal place. So you see that what? All those are 10th, 100th, 1000th, all of them are also other names for what? 1 decimal place, 2 decimal place, and 3 decimal what? Places. So the next one we are to consider, we consider the decimal place. Looking at this example, whenever you want to count, you start from the first figure after your decimal point. No matter the figure given to you, the first figure, the first number you consider is the number immediately after the decimal point. So you look at 1, they said what? We should express 0.09845675733 to A, 1 decimal place, B, 3 decimal place, C, 5 decimal place, and D, 7 decimal place. So when I count the 1 decimal place, the second 0 becomes my required point, and 9 is among the 1. So add 1 to that 0, it becomes what? 0.1. So the B aspect said 3 decimal place. So when we count 3 decimal place, we find out that 8 is our required point. Please, the reason why I'm not adding the 000 for all this number is because in decimal point, whenever figure ends with 0, it is inconsequential. It's not important. You can put it, but it's not necessary that you put it. For us being big boys and big girls, we are no more in primary school. That is why I don't need to put those what? Zeros for us in this case. So if you look at others, just count the decimal place, you find out that what? It is what? Correct. I hope this solution is very clear to us. Is it okay to us? If it's not clear, please and please go through it again, listen to the video again and again, and I believe you will get it. Because I always give more emphasis to first 2-3 questions, expecting you to use the idea to what? Attempt those things as your mental work. I hope it is okay. So now, at the end of this class now, these are the exercise given to you. Exercise 1 to what? 7. Exercise 1 to what? 7. Please and please attempt these questions carefully. I will request for you to submit to me. I might not want you to put it through my Google Classroom again. When I am ready, I will pass the message through WhatsApp. When I pass the message through WhatsApp, you will see the number. I will put the number that you will send the message, your answer to, and I will tell you how it will go. If it is still in the Google Classroom, I will also let you know by Monday after my class. Please take care of yourself. I hope you are taking care of yourself, and I believe that you are working hard, because it is by working hard that perfection will come. Solve more exercise, consult your textbooks, you can bring more exercise, you can request for our attention, and we will attend to you. Good day, have a nice day, and stay safe, please. Bye-bye.